in electronic cigarette use, particularly among cigarette smokers and younger kids who have never smoked. So this is of a special concern because there has been relatively short amount of time since there is not a lot known about the long-term effects of electronic cigarette use. So we're beginning to know some of the short-term effects that can be seen in a few years, but unfortunately, some long-term effects like cancer, you have to wait 20. You have to wait 20 years or more. So we don't have yet any evidence of this, but there is special concern that there's metals used in generate the what is called the vapor, which is as an aerosol. Because, like I said before, there's this metal coil that is used to generate the aerosol. And we know metals have long-term effects. So I'll be talking about that in a little bit. A few years ago, in August 2016, the FDA, the Federal Drug Administration, released the first rule that regulates electronic cigarettes and the components, but unfortunately, it's not a very thorough ruling because there's not. So we hope with this work to inform the FDA for potential leaching on metal components and some quality control they can be doing these devices. So as you can see in this slide, we have seen years a huge and rapid development of different electronic cigarettes have been modified, and they have been just the market is very rapidly changing. So it's really hard for researchers to keep up and to try to establish, to establish. Once we're just finally figuring out one thing, another one comes into the market. So the first few that you see here in this slide, and I have no idea if you can see my pointer, but the first generation were called cigalikes. They looked like cigarettes. They felt sort of like cigarettes. They were meant to make the smokers have the same sort of experience. But then soon they started to change, to evolve, and we had this second generation that were called pens, which is kind of like an intermediate device. It already has, here in yellow you can see liquid, and this tank contains the coil, and in the bottom is a battery. So all of these devices have the same sort of like principle. There's a battery at the bottom, then some way to retain a liquid that is in contact with the metal coil, that when the battery is activated, the metal coil heats the liquid and then generates this aerosol that is inhaled into the lungs. So the third two bigger devices, they're called mods, or modified or modifiable devices. The main difference between these bigger mods and the smaller cigalikes is the power. These batteries have the power amount in one puff, and so people are getting these huge plumes of aerosol. But the basic principle is the same. It's a battery that heats up the coil, that heats the liquid and generates the aerosol. And then finally, in the last year or so, year and a half, we have seen this explosion of the smaller devices, which in a way resemble a little more the cigalikes, the first generations, because it's self-contained. You don't have anything to refill. The tank is not open. It's a closed system. And you have these pods that they call that are changed on the top. The main characteristic of these devices is that they are small. They look almost like USB devices, like thumb drives that people use for electronic files. And so they have a relatively small battery, so lower power. So they generate less aerosols. So the plume that is generated is not as noticeable. It's not as big. It's not as visible. And so, unfortunately, these have been catching up with high school and even some middle school groups that using these devices. One of the other characteristics, besides being small, is that the nicotine that they use is a modified. It's not a natural nicotine. It's nicotine salts, and they pack a huge concentration of nicotine in each of the pods, more than twice of what the concentrations we were seeing in the mods. So the marketer is saying that with one pod is equivalent to a pack of cigarettes, so 20 cigarettes. The young people that are using these devices really understand how it's just a mechanism for getting them addicted to nicotine, which is kind of scary. But these have been in the market so little that we're just beginning to the metal coil that is used for these devices is the same as is used for the bigger devices. They are using these types of metal alloys. They are called nichrome, tantal, or some of them use stainless steel. So nichrome is a combination of nickel and steel. So nichrome is a combination of nickel and chromium. Tantal has iron, chromium, aluminum, and the stainless steel is a combination of chromium, nickel, and carbon. So all of them, as you can see, contain chromium, and a few of them are a problem because we know that these are toxic metals, especially when inhaled. So chromium is found in nature. Actually, all of the metals are found in nature, but chromium is a very special metal because it is found in two main forms. What is called chromium 3 and chromium 6, and they interchange. So if you find something in chromium 6 in nature, it can reduce to chromium 3, and the other way around also. If you can find chromium 3 that easily converts to chromium 6. And the problem is that chromium 6 is a known inhalation carcinogen. It's also called hexavalent chromium. I don't know if any of you have heard of this term. And EPA has classified chromium 6 as a known human carcinogen, and has said it's such a potent carcinogen, it raises a concern for the potential carcinogenicity of chromium 3. So this means that even if the chromium 3 that was in the coil the chromium that is in the coil is in the form of chromium 3, which is supposed to be toxic, it comes into the oxygen-rich lungs, so it would be easy to transform into chromium 6, which is oxidation process. I don't know if there's any questions. Let me know. I don't know, Carolina, if that's only for the end, I guess.
Yes, let's hold on questions until the end. And if everyone who's just joining now on the call, if you can press background noise, it would be much appreciated. Thank you. Go ahead, Dr. Rule. Thank you.
Thank you very much. Okay, so then the other component that is very common in electronic cigarette coils is nickel, which is also been shown to be a carcinogen, especially in occupational studies, which typically encounter higher concentrations of the metals. So one of the things that we are interested in knowing is what are the concentrations that we're seeing. Using these electronic cigarettes very often, you could get concentrations as high as some occupational studies. So this is one of the things that we're interested in exploring a little further. So other metals that we found in are lead and manganese. And lead, as you may all know, is a brain toxicant. So the main toxic effects of lead are on the brain of developing brain, so children and young adults. We also know that occupational exposures are associated with nervous system problems. And the International Agency for Research on Cancer classifies organic lead 3 components now: nickel, chromium, and now lead, that are potential carcinogens. And so the effects of these we wouldn't see until like 20-25 years after the exposure. And then finally, manganese, which is found as a contaminant in many alloys, and as you will see in a few slides, we also found in our study, inhalation to manganese has been linked to a very severe, irreversible disease that is similar to Parkinson. Is called manganism. This is also has been found in occupational environments, and also manganese oxides are very powerful oxidants, and so they have the capacity to transform this chromium-3 that I was telling you is not very toxic into chromium-6 toxic. So with manganese in the mix, it's a bad idea to have it, all of these metals. So in our study, we recruited 64 participants, and we collected questionnaires on each participant, on the type of e-cigarettes they used and the use patterns. We also collected urine, saliva, and exhaled breath. And we collected electronic liquid, the liquid that is put into the e-cigarettes, at 3 different time points. So we collect liquid that has never been in contact with the metal coil. We also vaped the device directly into a small tube that we collected the aerosol. Instead of going into the lung of somebody, we collect directly into a tube for analysis. And then we also collected directly into a tube for analysis. And then we also collected from the tank, what is left in the tank after vaping. And so we have these graphs that I'm going to walk you through a little bit, but we have the metals down here in on the bottom: manganese, nickel, lead, tin, and zinc. And on the Y we have the metal concentration in micrograms per kilogram, and these are the concentrations that we found in the liquids, in the aerosol and in the tanks. We found in the dispenser without ever being in contact with the coils. And for each one of the metals, you can see how it's lower than the concentrations in the aerosol. And these boxes are a very good way to show the variability of the data that we found. So you can see, I hope you can see on the axis, the scale is in a logarithm scale. So it's orders of magnitude. So this indicates the very, very different quality that we found from the different devices. So You find some devices with very little concentrations, but some devices with very, very high concentrations. But the distribution of those concentrations in every metal is lower for the dispenser, and then a little bit higher for the aerosol, almost in every case, and higher still in the tank. We are not so much concerned about the tank because the people are rarely come in contact with that concentration. But it was interesting for us to see if we could make the association that that's where the metals are coming from. One of the really surprising things that we found that we were really not expecting was to find these metals in the air. So this liquid has never even been in contact with the coil. So where is that aluminum, or in the case of iron, if you go to the last one, zinc, those are high concentrations for something that is not supposed to have any metals. So we are right now trying to decide investigate where those metals are coming from, because we don't think they should be there. We kind of expected to find them in the red in the tanks and the aerosol, but we were not expecting in the dispenser, so that was a surprise. We converted some of those concentrations. I should say, I'm going to go back to that slide. This is directly from the liquid, so the units, if you can see on the y-axis here, that's really low concentrations, and it's hard to understand those units. So we converted that is used by EPA and other health agencies to determine what our health effects of these metals are. So these are in milligrams of metal per cubic meter of air, which is the same units that, for example, EPA uses for establishing their limits on health effects. And here you can see regulatory limits that have been set out by the CDC. They have these ATSDR, the Agency for Toxic Substances and Disease Registry. They have, ATSDR has set some limits for these metals in air. So here we metals in air. So here we show in the box our results. In blue we have for chromium, and the red line is where the limit stands. So if you can see, almost 50% of our samples are higher than that limit. Nickel is about 50%, a little more than 50%. For lead, the line is purple because EPA has set these limits for ambient air, and half of our samples are above the limit. And for manganese, about 30% of our samples are above the ATSDR limit. So we find this that there was some concern. So in summary, metal concentrations varied widely in devices. The metal emissions tend to increase with the power of the device. There was no significant influence of flavors on the metal concentration. We also found very significant influence of nicotine content. So no matter what nicotine you put in, even if you're smoke or vaping with zero nicotine, you're getting the same concentration of metals as if you were not using nicotine in your device. Similar between the electronic cigarettes and combustion cigarettes, especially for chromium, nickel, zinc, and lead, which are all toxic to the lung. We did not find high concentrations of cadmium or arsenic, even though we did find some concerning because we were not expecting to find any. And so there are still some remaining questions that we have. We don't know, like I was saying before, we don't know where the metals in the dispenser are coming from. We suspect that it's poor quality control at the point of manufacturing. We also don't know exactly what are some of the user characteristics that determine exposure. So we are analyzing the data right now to establish that. And we don't know if there are other chemicals in the juice. Some of the flavorings are very sophisticated mixes of chemicals to produce these, I don't know, bubble gum flavor or candy, cotton candy flavor. So there's definitely some things that we are still cotton candy flavor. So there's definitely some things that we are still investigating. We have some ongoing studies. Like I said, we find some increased nickel and chromium concentrations in urine and saliva very early after waking, which is an indication. This indicator is used by many tobacco researchers is in an indication of sorry, I'm blanking on the name, but how addicted you are to the nicotine. We also found increased nickel and chromium, which higher urine coating of more nicotine consumption. So the more that you use your device, the higher concentrations. The heating coil more frequently actually had higher concentrations in their urine and saliva, which that was a little surprising to us also, because I thought that the older coil would leach more metals, but it's apparently the other way around. The newer coil is using more metals. Also, the people that consumed more e-liquid per week, the people who vaped at higher voltage, and the people who had higher concentration of aerosol, they also had higher concentrations in the urine and saliva. So all of these to us is sort of like a validation of the hypothesis that these metals in the urine and in the saliva are coming from the device. These might be people that, I don't know, work as welders or have other activities that generate metals, but the fact that they are correlated with the urine and saliva indicate that there's definitely something coming up from the devices also. So Carolina asked me some questions already. So one was, what the recommendations coalitions working to prevent substance abuse, particularly coalitions working to prevent youth e-cigarette use. So my main recommendation is education. I think if people know that this is a potential problem, they are hopefully less likely to start this activity. Although it's hard, because especially with the youth, we know that they have this risk-taking personality, and sure that exactly what would work. But I think by empowering people with information, at least you know that you are not just that this is not just water vapor. Like some of the advertising for the electronic cigarettes makes you believe that all you're doing is being water vapor. So future trends in research on e-cigarette use that community should be attentive to. I think there's a lot of research in the past year and a half on these pods, on the jewels, and there's others that are pods on the jewels, and there's others that are coming into the market that we are not sure yet. It seems because the power is lower that there's less metals than in the bigger. We also don't know what the vaping characteristics are, so people may be using them more because it's a little stealthier and you're getting less, less noticed about it. So people may be using it more. So even though they may be generating less metals, it could be the net effect would be the same. What research is still needed to impact FDA regulations? There's still a lot of research. We need to so that FDA can make a better informed decisions. Like I think there's got to be on the quality of the devices. Not like I was saying, it was surprising that so much metals were found in the e-liquid even before they were in contact with the coils. But also some quality control of the coils to estimate how much they are going to be transferred into the liquid and the aerosol. And then finally, where can viewers go to learn more about your research or more about health effects of cigarettes? I don't know. Just I guess stay tuned because there's almost a new paper on electronic cigarettes every day. They are, I guess, the good thing is it's definitely on the radar of the researchers. So there's people in different devices in the power. So there's lots of information coming out, and I guess you guys, CADCA, are a good resource. So hopefully you can help us disseminate this. And I think that's it for me, no? Yes. So we'll be happy to take any questions from the audience.
So there's one question, well, two questions so far from the audience. One is a clarification. Monica just wanted to ask, she wrote, do I understand correctly that metals were present even in e-liquid with flavoring only, that doesn't have nicotine in it?
Correct, yes, in it, or even before they are put into the coils, yes.
Okay, and then a second question is that someone wants to confirm that one juice pod equals a pack of 20 cigarettes. Pod equals a pack of 20 cigarettes.
Yes,
is that also correct?
You can go to the Juul website and they actually brag about it.
Okay, another question, one use, like smoking one cigarette, or does it last for multiple uses?
Well, so that's really hard to answer because it definitely depends on the user, right? I'm not sure exactly how people are using it, but I have heard that some kids do finish one pod a day, which means they are vaping the equivalent of 20 cigarettes of nicotine, worth of nicotine. But of course they could be vaping less, so you can use your electronic cigarette only once a day, right? Although with that concentration of nicotine, it's hard to believe because what you're getting is addicted to the nicotine, which you need another puff every 15 minutes or something, which is the time that nicotine takes to clear from your system.
If anyone else has any questions, you can type them in the chat box in Skype. I guess also it seems like somebody is still not muted, so if you have a question, you can go ahead and just ask it out loud instead of typing it. Well, I have another question then. Dr. Rule, you mentioned in the presentation that you found arsenic in the liquid, and I'm just wondering where you think that that's coming from, that's not in the coil, in the metals you mentioned, correct?
Exactly. So arsenic was one of the, I don't have it in the presentation, but it's in the paper. Arsenic is one of the filtration before and after being in contact with the coil, which means it's not coming from the coil. It's somewhere in the production of the liquid. I'm not sure where arsenic could be getting in, but these